Okay, then, I'll take that off. Right, masks. There's only three types of masks. We use it for manipulating bits. That's what its purpose is. These bits generally, we're talking about CPU level things, but some languages do give you access to bitwise operators, like C, all the C-based languages do. Okay, so it's manipulation of bits, and there are only three operations that you do on bits. So these three operations are setting bits, so that's like forcing them to be a 1. Clearing bits, so that's forcing a value to be 0. And then the final one is toggling. So if a bit was on, turn it off. If a bit is on off, turn it on. Okay, so that is 1s to 0s, 0s to 1s. Someone mentioned in the other class about why don't you just use not on each individual bit. I'll explain why when we get down to it. Right, so the only thing that you've got to remember is two things. What operator is it? And it's just the logical operators. So to set a bit, we use or. To clear a bit, we use and. To toggle a bit, we use exclusive or. Okay. Obviously, to actually perform the operation, you've got to take the pattern of bits you want to manipulate and apply the mask. So we need to supply a mask to say how to manipulate the pattern. And choose your operator. And really that is all there is to it. So I just want to go through some examples. Right, so let's have a look at setting a bit. So let's have a look at setting. Let's go up. Right, so we want to force a position to be a 1. So we said already that is the OR operation. So let's say we've got this bit pattern. We don't know what it represents. It could be anything. It could be maybe this represents 8 cameras that we want to be active, and the top 4 is a zone, and the bottom 4 bits are another zone, and we want to turn the top zone on. So let's say we want to force, or we want all of this, the upper nibble. We want to set it to all 1. Okay, so we need to provide a mask. So we use an OR to set. So what feature of OR, the logical operator OR, is going to allow us to force those upper 4 bits to be 1s and leave all the others?
What's either the digits in either the mask or the number you're using is a 1, then it will flip out a 1.
Excellent. Yeah, so if we've got a 1 in any position and we use OR, it doesn't matter if the original bit pattern we've got is 0, because we'll say, right, oh, that's 0, but we've got a 1. We've got a 1 somewhere. So a mask to do this operation, to force that upper nibble to be 1s, would look like that for the area we want to force. And then, because we don't want to touch anything else, we'll just say, right, oh, okay, let's leave that as 0s. And just to prove that, so you can work it out. If you can remember the operator, you can work out what the mask is. So if I do this, 0 or 1 is going to be 1. 0 or 0 is 0. 1 or 0 is going to be 1. 1 or 0 is going to be 1. So that has remained as it was. Now this bit, because we've got a 1, the outcome is going to be 1. Because 1 or something is always 1. So that, and that's it. There's nothing more to it. So OR can be used when we're setting. So we might have in a bit of assembly language to do this operation, because obviously the computer's not doing it like this. You would, let's say we've got a value in A. You might write an operation like this, and I'll write this in hexadecimal. which is why we use hex, you do that. So you'd represent that mass by saying F0, which is what it is. That would be one of the quickest operations. Okay, so maybe 4 cycles on an old school machine. On an ARM processor, it'd be 1 cycle. You could individually set those 4 bits. So there may be, in the machine language, there may be something where you can say set 7, set, and we're saying bit position 7, bit position 6. So you could do that, but it's not efficient. That would take, if we use the same analogy, 16 cycles. And actually someone did say, wouldn't it just actually create a mask like this and apply it? Yeah, internally that's probably what it does. So it's just a fixed mask. So it allows us to manipulate multiple bits at once. Okay, and this, we're just talking about 8 bits, but obviously modern processors, 64-bit processors, so you could actually manipulate 64 bits all in one operation. So it's actually quite a quick operation. So obviously you get access to this, and you'll see in C# and C, you have, so if we wanted to do a set operation, we'd use that in C#. So that is called a logical, it's just a pipe symbol, logical or bitwise. No, it's not logical OR, it's bitwise. Bitwise. Oh dear, half asleep as usual. When we want to use a normal OR, we have to put 2. I don't know who made that decision to make it that way round. It's more common to do a logical OR than it is to do a bitwise OR. So that is a logical where we just say this or this. So we're comparing Boolean values. Okay. Right, okay, so that was setting. So the other common operation is to clear. So the logical operator is AND to do this. So let's say, let's have another bit pattern. I don't know what it represents. And I want to set the middle, I want to clear the middle 4 bits. So I want to clear these ones here. I want to leave the others as they are. Right, so if I want to clear them, so I've got to think, what are the features of AND that would allow me to clear a bit in a certain position? So what's the overriding thing with AND?
Like bits have to be 1 for it to be on.
Yeah, both bits have to be 1. So we can actually go, ha 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 ha, if we put a 0 in a location, it's going to clear it. It's going to force the result to be 0. So let's like try and see what the mask would like. So we want to leave them alone. So we put a 1 where we just want to leave it, and a 0 where we want to force it to 0. So let's try it. I'm not adding them up, remember, I'm ANDing. I'm applying AND. So I go 1 and 1, so on the truth table that's 1. 1 and 1 is 1. 0 and 0, obviously that's 0. 1 and 0, well that's 0. 1 and 0 is 0. 0 and 0 is 0. And then we got 2, 1. So it does, it clears. Okay? So again, this is quite useful, and one thing that we use in assembly language quite a lot, you know when we're doing mod, and you do like, oh, you know, give me a remainder out of 8, I want to know, I just want a value to cycle round. Now actually you can use AND to do that. So you've got a number, let's say you've got a byte, but you want to know what the remainder of divided by 8 is. So all you actually have to do is go like that and then compare, and then you've got a number between 0 and 7, which is mod 8. Super quick operation, just by doing an AND. Okay. Right, so that's clearing. So for me, these aren't hard. I've done a lot of assembly language programming, so for me it's bread and butter. But it's just a matter of AND is clear, OR is set. If you can just remember that, you can actually work it out again. You can just try it in your head and you go, oh yeah, that's going to clear. So you've just got to remember the operator. You don't have to remember the mask. That you can work out again. Right, so the other one is toggling. Right, so toggling bits. For this one we use exclusive OR. Now you've got to remember the properties of exclusive OR. So when you're looking at the truth table, what's the two outcomes that you get?
No, you get, if both are 0, then it's going to be 0. If both are 1, then it's going to be 0. And otherwise it's 1.
Right. So the weird thing with exclusive OR is you get a 1 as an output if the inputs are different.
Yeah.
If they're the same, you get a 0. Okay. So let's say we want to toggle the lower nibble of this bit pattern we've got. Okay, so we want this set here to go 0, 0, 0, 1. Don't know why, but that's just what we want to do. All right. So anyone guess what we're going to do to force that to happen?
Were you trying to make the last one 0, 0, 0, 1?
No, we want to. We're just going to leave that.
Okay.
Right. So what would we put here to make these flip?
Right, so where there are 1s, you'd need 1s on your mask. And if you wanted to make these 0, 1, you'd stick them on there as well. So it'd be actually 1s.
And what about here?
There's one at the end, isn't it?
Well, no,
That'd make everything.
Are we just trying to leave that the same as it is?
Yeah.
Okay, right. In that case, you'd be putting noughts where the 1s are and 1s where the noughts are.
Right. So let's just try it. See if it's any good. Right. So they're different. So we get a 1. They're the same. So we get a 0. Same. Same. Different. Get a 1. Different. 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 That didn't work.
Can I print something off? Is that okay?
I'm in the middle of recording a video.
Oh, okay. Sorry.
Right. That didn't work. So what could we try instead? Because obviously that's not what we had.
Yeah, right. Okay. Well,
The first bit worked, didn't it? Put
Yeah.
in the 1s.
right. Okay. So
But what should we guess?
leave that where we were. We want that bit.
Just put all 0s.
Yeah.
Let's try all 0, right? See what it does. Right, so I'm not going to do that bit again, obviously. Right, they're different. They're the same. They're different. They're different. That's the only thing you've got to remember. Okay? It doesn't, when you're thinking about it and you're looking at Excel, because Excel is quite a weird thing. You look at it, you think, is that going to work? Is that going to work? But, yeah, it did, didn't it? Okay? So if you put 0s and there was a 1 there, then they're going to be different, aren't they? And if there was a 0 there, it doesn't matter anyway. But with the other one, it is. Right, exclusive OR is a bit of a weird one, but we used to use it when we wanted to draw bitmap graphics, and it was on slow machines where to undraw something was slow. So what we do is you just apply something to a scene using exclusive OR mode, and then if you applied it again, the exact same thing, it would undraw it and leave what was there. So if I was to do exclusive OR between these two values now, you'll see some magic happens, and this is the great thing about exclusive OR. So if I go 1 and 1, they're the same. A 1 XOR 1, they're the same, so that gives me a 0. They're different, gives me a 1. Different, gives me a 1. Different, gives me a 1. Different, gives me 1. They're the same. Different, different. Got back to what I originally had. So when you apply XOR twice, the same value, you will reinstate the original bitmap that you had. So it is useful where you want to do something and then you want to undo it. So you know, like when you in a word process you highlight something, actually what you're doing is you're applying exclusive OR onto the thing. Which is why if you select an image, it goes inverse. Because what it's doing is just excluding OR with the dark colour or the dark blue, whatever colour it's picked. So you get an inverse video effect. That's it. Yeah, that's all you need to know for the masking stuff. Hopefully I've recorded the audio.